The whole function of drawings is to convey ideas. Let me just start again here and say that the whole idea of drawings is to convey ideas. That's the relevance of the engineering drawing function. So what we need is good recognizable pictures which reduce ambiguity while discussing a project. In this particular case, we're talking about project concepts. Getting one idea from one organization to another could be the construction of a factory, could be the construction of equipment to go inside a factory. But we use drawings to convey ideas, ideas which would be difficult to explain in words, and so that's the necessary part of this. Okay, so when the completion of a project comes, then if there is construction and assembly involved of components or indeed systems, then the drawing becomes part of that documentation. So it is in fact a tool for solving problems, not only during design and manufacture, but also as part of ongoing safety, service, maintenance issues. All of that revolves around good engineering drawings. I'm sure you're familiar with this concept, but I would like to point out a few important things that we need to say here. So there are sort of probably four main stages in plant engineering, construction and operation. First of all, the tendering stage. This is clearly where we hope to provide definition of what we're trying to do, and certainly drawings and diagrams show what is being received by a user, what is being sold by a contracting organization. So, you know, future disputes are avoided because we all know what we're dealing with. We know what it's going to look like. At the design and the engineering stage, then what we need is a bill of materials, a detailed bill of materials, which is used by the procurement department. It forms the basis of an inventory, so we know what we have to maintain. And then, of course, the construction and assembly stage is where we're using personnel at the construction site to build something. And then, as I say, the ongoing aspect of this is operation and maintenance stage. So if things go wrong, if things want expanding, we can do that from the starting point of looking at the drawings to know what's supposed to happen. And then we can develop the situation from there. So key part in any organization. For the manufacturing organization, there's a typical cycle of activities in a manufacturing organization. The ideas go on to drawings, the drawings go into manufacturing, you end up with a finished product, you end up with a distribution system. The distribution system leads to customers gaining documentation. Now, very often customers say, well, okay, I bought one of your devices, but I need it to do this, or I need it to be to cope with that. And so modifications occur and the product develops. And so this cyclic arrangement here is quite an important part of management. And of course, the drawings must be updated and changed, and the management of that change is a key activity within any manufacturing organization. Standards. So what's your view of whether a standard is a legal document? What do you think a standard is? If something is made to a standard, is that standard a legal document? What do you think? Yeah, minimum requirements. Okay, Travis. Okay, I accept that. What does anybody else think? What is a standard? Is a standard a legal document? Guidelines. Kevin says it's guidelines, so it's not mandatory. Anybody want to add to this? It's an important point, actually, and the understanding of concepts like the legal concept of a standard, I think it is interesting. Travis says he believes it's a legal document. Well, it is if it's cited in a contract. Can't be avoided. Well, I see what you mean, but let's be clear about this. A standard only becomes a legal entity if it's cited in a contract. So if I'm going to say to you, I'm going to build a piece of equipment to meet a certain standard, and you say, okay, I'll buy that piece of equipment from you, then we've entered into a contract, and that standard becomes a legal entity as far as that contract is concerned. So if the piece of equipment doesn't meet the standard, you're in breach of contract. So that's important because clearly standards guide market growth. And they certainly keep on top of new and emerging technologies which are proven. Certainly for a company to manufacture to a standard or to develop a product which meets a standard, there's reduced development time and costing. Sound engineering practices are likely to be used which are acceptable by both manufacturers and users. Trading costs and lower trade barriers, if that standard is accepted. Miguel has said it's a defined practice which everybody accepts, and I would certainly agree with that. It's likely to promote increased product quality and indeed safety. That's a very important point. And the reduction of market risks is said to emanate from standards, as well as to some extent protection against obsolescence in product manufacture. And drawings too are the subject of standards. We will talk about this through this section, and no doubt on other sections of the course you'll be looking at drawings which emerge. So being able to read drawings and understand them is of course second nature to engineers. The concept of a drawing office, though, is something which is fading. You may remember, the classic shots, classic photographs that you've seen of the aircraft industry, where people were working at drawing boards, and there were sort of hundreds and hundreds of drawing boards in factory floors, all lined up neatly, all producing manufacturing drawings. To some extent, that has been superseded by what we call computer-aided drafting, which is the correct name for CAD. So uniformity of graphical depiction has been maintained, or is a requirement to try to maintain by drawing office principles, and other facts like you only put what information is necessary to be displayed on a drawing. You don't clutter the drawing with information that should appear in other documentation. Correct dimensioning should be done so it's easy to understand, and the use of standardized symbols, standardized abbreviations should be used, which are agreed between manufacturers and users. So industry standard abbreviations and symbols. And some of them now are being used in international standards. So IEC 617, for example, is a good example of a drafting standard. Computer-aided drafting has promulgated standards which we work to. There are various aspects of drawing numbering systems. There are standard borders which can be developed. The symbols that are used on those drawings, all of these can be standardized for an entire project, for an enterprise. And it's optimized for that particular industry. For example, the power generation industry have their own symbols. The petrochemical industry and the pharmaceutical industries, to some extent, have developed their own symbols. So, appropriate scales, drawing sheet sizes, things like that, all have to fit in with documentation practice, and of course most computer-aided drafting systems will meet those requirements. So standard dimensioning notations, ways of illustrating equipment, thickness of lines, text formats, all have to be agreed and implemented and totally consistent. So on a typical engineering drawing, you will have a margin, you will have a borderline system, you will have an orientation mark, you will have a frame grid reference system, and you will have the north symbol and key plan markings so that you know if it's a scale drawing of a building, you know exactly which way you're facing and you know what you're dealing with. So every drawing is consistent, and here are those parts of a drawing. And the margin itself is so that if the edge of the drawing gets damaged, you don't lose any information. The untrimmed sheet of the paper is what gives the paper size. The trimmed size of the sheet is again the sizing that's used for scaling and things like that. And the border with grid lines is so that you can find things on a drawing easily.